Good morning, everybody. Good to see you all. Like Jim said, my name is Jim Tkach. I have the privilege of talking to you today about the beauty of structural concrete. And that's something that's near and dear to my heart. Been in concrete business for probably 28 years or so at two different companies. Today's presentation is a short presentation just designed to get you to consider or reconsider showing off concrete in your construction projects. To do that, I'll focus on the following topics. First, why enhance and expose structural concrete? Second, what are some of the best practices in coordinating cast-in-place exposed concrete? And third, how different design choices impact costs and constructability. So the context of this presentation is primarily my own experience, and I know there are a lot of different ways to do concrete sectors. My area of experience is in the commercial, institutional, public and private markets in Southern California with a specific focus on cast-in-place structural concrete. So for today we'll focus on that sector, but this could apply to other areas as well. So first of all, enhancing exposed structural concrete. Let me start with a crazy example to make a point. If you had a car that looked like this, my guess is we'd have a lot more folks interested in cars and how they worked. Why? Because you get to see past the cover. What's inside is interesting. It's probably impractical for automobiles, but not so much for buildings and the structures we build. Today I'll highlight some of those, and I'll challenge you to consider that more often than not, I'd like us to expose the concrete we see. We ought to see more of the concrete in the structures that we build. It's a way to show design efficiency, simplicity, a measure of minimalism, and the craftsmanship that makes a useful structure. So why show off structural concrete? I would say, one, people appreciate what they understand. And people better understand what they can see. And people remember the craftsmanship of what they can see. So we in the concrete industry have a product that's efficient, safe, it's useful, and when done well, exhibits craftsmanship. Not many structural building trades that I know of are able to show off craftsmanship as we are able to do. Most structures we occupy end up being covered, like the room you see here, for fire protection or for thermal issues or aesthetics. You're not really interested in seeing much of what's behind the facade. But with concrete, there's a natural beauty, a non-homogeneous variation that can have nearly unlimited shapes and finishes. So why expose it to people? Because craftsmanship is worth seeing. Next, I wanted to talk about the concrete elements in the building we want to expose. So you have something that's worth looking at. The issues in coordinating and building exposed concrete is what we'll look at next, best practices. And put another way, what are some of the basic things we need to remember when planning to expose cast-in-place concrete? So first off, concrete gets stale. We all know that. Concrete has set times, flashpoints that we need to control. It drives the entire process of what we're doing here. So in many ways, concrete placement requires more of a transportation solution and as much as a material design solution. And what I've shown up here is an overview of a large job site. And you can see points of placement. You have points of placement in this area, 4 different points of placement. Discharge points where your trucks are coming in the site, from off-site, circulating through the site. If you can find all 10 concrete trucks on the site, you've got pretty good eyes. There's another placement point here. There's off-site roads where people need to come around and get to the point of placement. There's a community nearby that's probably not used to construction of this magnitude. And all of that has to be taken into account when figuring out where you're going to get your concrete from and how you're going to bring it to the job site. But not just on the job site. Somewhere nearby, there's a batch plant, and there's a similar choreography going on, where trucks are coming in continuously throughout the day, dropping off aggregate, loading them on underside, using conveyors to place them into material storage locations. And you see here that there's batching tolerances in concrete. If you're considering exposing concrete,
one of the things I put this slide in here is just to take a look at.
This is one day's load. This is the new loads that are coming in today, same rock material. Granted, this is dry material here, and this has all been wetted, but in both sections of wetted material, notice there's a variation. And some of that variation happens naturally because we're dealing with a natural material. And so that's normal. This isn't a presentation on batching for concrete, but if you're interested in more of a guide on how to handle issues with transporting and batching concrete related to temperature, water, etc., excuse me, ACI offers resources in 301, 318 that'll allow you to take a look at that. So where do you primarily focus on this transportation problem? If we deal with transportation, getting the concrete to the site, I'd like to focus on three primary areas that you want to take a look at. Again, on the basics, there's a lot more to all of this today, but in a short presentation, just focus on these three, you'll be off to the races. You're at a good start. So cement paste, which is where all the cementatious materials, admixtures, water in the concrete mix is together. That determines how the mix behaves. Form material, choices you make here affect the surface of the concrete. And then, of course, visible features, which are the exposed elements that people will see and what people will remember. So to start with cement paste, we all know how concrete is composed of in hydraulic cement. Within that area, you have cementatious materials such as fly ash, slag, silica fume, other pozzolans. We've all seen this type of picture before, where you have different SCMs that affect the concrete mix in one way or another. You need to be aware of your standard concrete mixes in structural concrete. Standard concrete mixes often contain one or more of these elements. And it's not just the color that they'll affect, it's the behavior of the concrete. And so, for example, with fly ash, a mix that has a normal variation in fly ash can start looking like this between the lines. And this might be a little bit of a mixture problem, but it's not out of tolerance and it functions perfectly well. If you're going to expose concrete, you just need to be aware of the standard type of mixes that you have and what's contained in them. Example of blast furnace slag, in one case that reacted in an interesting way with the concrete mix in the aggregate. This tends to happen early on when the forms are stripped. And then it tends to go away over time into a muted gray, but you just need to be aware of a standard concrete mix that's going to get covered. People don't pay attention to some of the SCMs that might be involved in that. To look at it in a more conventional sense, I've got a picture of some standard concrete mixes back to back with some different types of mixes. On the left-hand side, first of all, we have a standard type 2.5 concrete mix on the bottom of the column on this side. And then right above it is placed the type 1 concrete mix. And the type 1 was placed above the superstructure for the color. It has a little bit lighter effect, as you can see. And the standard type 2.5 was placed because it has a higher sulfate resistance to the soils and underground. So foundations were done 2.5, and at the first column lift, they switched over to type 1. Why? Most of the superstructure, you'll see in some slides later, is going to be exposed, and they like that a little better. We have the opposite on the slide right next to it. You've got the type 2.5 on a deck pad, which will get covered up with finishes, that transition. Before it was covered, you can take a look at what's below it, and a wall that will be exposed is a blended cement, a Portland limestone cement. Underneath it, you can just see right off what the difference in those two cements are. So when you're specifying concrete in a standard form, if you understand what type you're doing, you can see that there are some differences between here a 2.5 type 1, a blended cement, and of course the classic white cement, white cement used in a wall form gives you this beautiful curved wall that I don't think anyone would ever want to cover. So next we want to look at form material. This is where we think about what's going to be seen by the people in terms of texture. From a distance, this building looks pretty well ordered. The face is smooth and crisp, and you're in the mountains at this particular ski resort, and you see up close that you notice the grain from the plywood. I don't know if you can, yeah, I guess you can see that. That works pretty well. Now this has been here for about 50 years, so harsh winters, freezing, and over through summers have probably accented this texture that you're seeing here. in particular, but for the most part, that's the use of a certain type of plywood, and that'll give you that texture. If you're not into that texture, of course, using a different plywood gives you a smooth face, right? And that's a harder plywood with a surface that is stripped. These are all as-cast structures, so if you take a look here. Next, I just wanted to bring your attention to on a smooth face then. The next step is really looking at these ends. If you see, these are all full-size plywood sheets lined up with each other across the soffit of both floors. And in typical production concrete, you might have plywood cut ends, you might have half sheets at the transition, especially around the columns. And you see some of that down here. But one of the things you can do is start on one end of the structure. In this case, they start on the outside edge of the deck and move plywood evenly and systematically towards the center. The next step beyond that, of course, is dictating when you make transitions. So in the construction photo of this is the same building in both slides, you'll see all the plywood seams lined up in one direction, and then when you get to a lobby area, there's a cant at a certain angle, and that continues on. In the finished structure, you see along the corridor here, as cast concrete, not sealed, the floor is sealed, so it gives you that sheen, but this is the type of plywood used, gives you that muted matte finish. And you'll see the light fixtures lined up every third plywood line, and the mullions are lined up exactly on each one of these lines as well. So that's an option for you, but again, takes on another level of constructing something that's going to be exposed. I included this photo just to show you some of the far-end, the high-end type of things you need to be aware of if you're going to be exposing concrete for architectural purposes. You'll notice the worker on the right-hand side has coverings on his shoes, knee pads. They're using painter's tape to mark out the form where they're going to be drilling tie holes. Because if you scuff the surface of the form, guess what? The surface of the concrete will oftentimes relay that. You write anything on form work, it'll transfer through on the slab that you're there, which is fine for typical standard concrete that's going to be covered. But if you're considering your structural concrete and the option to kind of expose it, these kinds of things you need to be aware of. Also, different size cuts. If you're going to do custom size plywood, you can see on the left-hand side there's some angled, triangular shaped plywood. That's cut off-site for production purposes and covered and sealed and protected so that during the construction process you don't have weathering of your forms prior to when you need them or they're damaged. So these are the kinds of things you might need to do on a high-end architectural process. This is not a presentation on all of that. I'll give you some resources later. Of course, besides the smooth form material, you often have the desire to have it's like a form liner or a board form or a wood form surface, which there's different levels of texture that you can apply either by pre-manufactured liner or with actual pieces of wood. So if you have an interest in those types of things, ACI provides two great resources for getting deeper into the topic of form material. One of them is from 347, entitled A Guide to Form Concrete Surfaces, and the other, of course, is the Architectural Concrete Practice Guide from ACI 303. So both of those documents you should be well aware of. Third, in this area, just the visible features. What are we going to see? What are we going to focus on? And I like this area the best, I think, because it's really what people tend to remember about the building. When the building's completed, these are the features that stand out, and people remember that as something they have been asked or could appreciate. What it takes is coordination, and when you're looking at coordination of these features, similar to what Carrie spoke about, previous to the construction process, pre-construction, when you're starting out, you need to take a look at every detail. By example, I'm just going to show a picture of a stem wall that had a cap with a recessed light surface. And how are you going to build that in the field and leave it exposed? During construction, you'll see it's a curved wall, and it turned out that you needed to pour it in different lifts with a cap poured separately. So you've got a separate cap that's poured after the fact, which allowed for that detail to go back a slide. There's a recessed area there for LED lighting to fit into. And within that detail, you couldn't do that with one pour, and you couldn't make it look right. At the end of the day, you end up getting curved walls that have lined up tie, which you see like a combination of all the things we've looked at previously. In addition to that,
you've got a recessed lighting that adds to that feature.
Worth exposing, that kind of stuff. Lastly, you can use texture as a visible feature itself. I believe this surface was a form liner, and then the protruding members were physically broken off to give it an even rougher look. And over time, that's something, if you appreciate,
can be an option that you use.
Again, if you don't like that, we go back to smooth
form walls.
And in this case, I wanted to just point out a couple of things here. The architect chose to put the full-size sheets right in the middle, so that when the floor comes in, you're going to have a full-size sheet in the middle on one end of the floor. You have these lined up very nicely,
and everything looks clean.
And he's able to get his large-size sheet. This is rather than going to custom-size sheets or something like that. You can stamp-size sheet, but you line up where it starts and where it stops, as an example of that. In addition to just lining up the seams, this picture shows a couple of things I wanted to highlight. One is the reveals. They're stripped right here. They're not stripped yet, so you can still see the wood is inset. That will be stripped out, and you'll see the clean line around. But also the tie holes. And notice the tie holes at the end of the wall. You can't put a tie hole through the end of this wall and use that. That's not used for forming. That's used for architectural purposes to line up on either side of the door. If you come back to, this is typically what you'd see at the end of a wall. There wouldn't be any tie holes at the end of that. But in this case, the architect wanted to use tie holes, plugs, without the tie itself, just for a feature. And then lastly, if you're talking about lining up seams, this was a project we looked at earlier in the slide presentation. And you can see where the different plywood seams seem to be randomized in different sizes. And so there's a intentional focus on creating a random look. And believe it or not, this architect wanted to create the look of just random pieces that would be used in production from an earlier era, and created that with form line drawings that were different sizes and shapes. And so that can be done as well. Here's an example of two types of edges. So the edges of products, so you can see on the same column, the lower half has what we call a chamfer corner, 45-degree angle. And the top portion of that column has a square corner, which is 90 degrees. And it's very difficult to do a square corner. Obviously, you have a lot of bleed in the paste. That corner has to be done extremely well. The column formed to the right-hand side is showing the chamfer corner with a plastic inset. The chamfered corner allows the column form to be removed more easily. But it's a different look. And when you start getting into 90-degree corners or square corners on a wall like this, it's incredibly difficult to make this come out clean. And so the length of this wall, the smoothness, the straightness, this is cast in place concrete at its best. There's no bleed in the corner. And when you have a structure like this, it's worth showing off. So you've decided to show off some features, and invariably someone asks, what is this all going to cost me, right? And so I'll give you a standard disclaimer. Every region obviously is a little bit different. You have different supply and demand, different skill levels, and so actual costs between regions would be helpful to you today. So what I decided to do is just put a relative comparison. I think it's useful to talk just in general about some of the things that we've seen here. On the left-hand side, standard sizes, no partial piece requirements. Using standard plywood is the less expensive. On the right-hand side, the more expensive sections, intentional seam layouts and tie hole layouts, non-standard sizes of plywood. If you're specifying special hardwoods or laminates, those are things that are going to be a lot more expensive. And somewhere in the middle, you have perhaps full-size sheets starting at one end, high HDOs, MDOs being used for plywood surface. And along the bottom, it's a little bit tricky with form liners and board form because they can run the entire gamut from being a less expensive form liner might not have the kind of repetition that you see. It may not look as quote-unquote real wood as actual, just using actual wood. And sometimes using actual wood in a certain region that's readily available can be less expensive than actually a form liner. So there's that, and then we talked a little bit about the chamfered corners and square corners, less expensive versus more expensive. If you're using one of the projects we saw there where they had the formwork with the gentleman that had knee pads and covered shoes, you notice that was a back-formed, back-screwed formwork, where they were underneath with a form panel that they used a separate smooth piece of plywood on the front and screwed it from behind so that you don't have screw holes come through the concrete face. So that's obviously at the very expensive end of the concrete material form. And then also with materials, again, this is a little bit tricky because the standard Portland cement is usually the most economic. And we're talking white cement on the right-hand side, the most expensive. Somewhere in between, you can get some of those colors we talked about. Specifying a type one that might be lighter, might have more gypsum, or a Portland limestone cement, which if it's available in the area and readily used and designed, might give you a different color without a whole lot of extra expense. So put together, we have an example of a building here with a good amount of exposed concrete. On the interior side, you'll see interior and exterior. And it kind of complements the idea of exposing their concrete. And one of the things that people often don't think about when they're thinking about whether to expose the concrete is the lack of finishes on top of that concrete costs something in a building. And there's usually a very big cost to covering concrete with finishes, drywall, painting. And leaving that unexposed leaves all that cost out of your project. And so if you take a close-up of this right-hand side picture, I took it three different points to take a look at. First of all, on the soffit, you'll see on the right here, they've done the seams lining up with the light fixtures. There's no hanging ceiling material or anything else to kind of worry about in that sense. In the middle section, they've done a combination of a 90-degree corner on the slab edge, but the columns are chamfered, and these are chamfered columns that still look pretty clean. This is very good workmanship here along the interior, trying to get columns and slab edges to come out cleanly like that. It's pretty nice. And then at the bottom of the column, they've done a polished floor, and it's not necessarily a heavy grind on that floor where you're seeing something like terrazzo, though you could. It's a light grind to just give it kind of a variable look, and in this case, the architect appreciated that kind of look. In a different space, this happens to be a library, where you see the exposed ceilings, what we'll call maybe a void form or a waffle slab, just with some simple fixtures hanging from that. Still gives a warmth in the space with carpeted, and then a column that's exposed, and a reading well to the right, where you're seeing some of those tie hole layouts lined up nicely with a lot of light coming through, and the natural concrete with the 90-degree corner on that seating area gives you something to sort of contemplate for interior spaces. For outdoor spaces, one of my favorite examples of exposed concrete from the past is, which actually I think this project led the way for exposed concrete. It's over 60 years old, and it's the Salt Institute in La Jolla, California, and you can see how it's over time it's led to other projects being inspired to use simplicity and exposed concrete being used. But that's not just something that happens in the past. Currently under construction in San Diego is a building that's going to have exposed columns that you see the soffit underlying here with the lined up plywood. Standard concrete, nothing's particularly any more expensive about that. With this faceted column, why close it? At the end of the day, it's going to be a feature that opens up the downtown area along the corridor. And rather than block that out with a building or here's a rendering of the final product. Rather than block that out, that corridor right down the center of that street is going to be exposed, and the concrete's going to be there to see, for people to see how that building is constructed. In the future, I hope to see a lot more exposed concrete. This structure is one of the ones we had a close-up of earlier in Los Angeles. I think it's probably 2023, 2024 will be exposed. Here's a rendering of what that will look like. The entire structure is exposed, and the concrete will be visible for everyone to enjoy. And I think if you understand that, I think people, like I said, appreciate what they understand, and they better understand what they can see, and people see and remember craftsmanship when it's available to them. So those are the kind of things that I wanted to point out to you today in a short presentation. Hopefully it's whet your appetite a little bit for taking the concrete in your projects and showing it off a little bit. So thank you.